Hi everyone, in this video I will show you how to use a push button with STM32F4 discovery board. In the last video we have seen how to use GPIO pins of this discovery board as a digital output pins, and we learned to use onboard LEDs of STM32F4 discovery board as a digital output pins, and we have seen how to toggle or blink those LEDs with a rate of 1 second or 2 seconds. So in this video we will see how to use an onboard push button of this discovery board to control those LEDs. So let's get started. So whenever you want to interface a push button with any microcontroller, we actually want to read the state of push button. For example, there are two ways to interface a push button with any microcontroller. First one is a pull up mode and the second one is a pull down mode. In pull down mode, we have a push button and a resistor, and a push button is connected with 5-volt source, and the other terminal of the push button is connected with the ground. So in case of pull down mode, when push button is not pressed, so the logic output that will appear at the microcontroller input pin is a ground through this resistor. For example, when push button is not pressed, so this ground logic will appear at this input pin, which we will give to the microcontroller. And when the push button is pressed, these two terminals, terminal 1 and terminal 2, will become short, and this 5-volt logic will appear on the microcontroller input pin. So in case of pull down mode, under the normal conditions, ground logic will appear or active low logic will appear at the input pin of microcontroller, and when the push button is pressed, you will get a 5-volt or active high logic at the microcontroller input pin. In case of pull up mode, push button is connected with the ground and other terminal of the push button is connected with 5-volt through a pull up resistor. This mode is known as pull up mode because push button is connected through a pull up resistor. And now let's see the working of pull up mode. In case of pull up mode, when the push button is not pressed, a 5-volt logic or active high signal appears at the input of microcontroller through this resistor, because when these two terminals are not short, so this logic, 5-volt logic, will appear at the input pin of microcontroller. But when you press the push button, these two terminals will become short with each other and you will get a active low or ground reference at the input pin of microcontroller. So in case of pull up mode, normally when the push button is not pressed, we will get the active high signal at the input of microcontroller, and when the push button is pressed, we will get active low signal at the input pin of microcontroller. And in the case of pull down mode, when the push button is not pressed, you will get active low signal at the input pin of microcontroller, and when the push button is pressed, we will get active high signal at the input pin of microcontroller. So STM32F4 discovery board has onboard push button. As you can see in this picture, push button is connected with port A, pin number 0. So this push button is already available on discovery board, and we will use this push button to control these 4 LEDs that are LED 3, LED 4, LED 5 and LED 6, which are connected with pin number 13 to 16 of port D. So this push button, which is connected with PA0 or pin 0 of port A, is connected through a pull down resistor mode. As you can see in this schematic, there is a push button and a pull down resistor, and the other end of the push button is connected with VDD. So when you press the push button, you will get active high signal at the PA0 pin. When push button is not pressed, you will get active low signal at the PA0 pin. So that means when we want to use a push button, we actually want to read two states with the help of microcontroller that are active low or active high states. So GPIO pin, by configuring the GPIO pin of microcontroller as a digital input pin, we can read those active high and active low states. So these resistor, other than a resistor and Now coming back to our main discussion, so now let's create a project in Keel Microvision, and using GPIO HAR libraries we will control these four LEDs which are connected with PD13 to PD15 pins with the help of this push button which is connected with PA0 pin. Now let's create a new project in Keel Microvision and write program to read the state of push button and control those LEDs. First of all, open Keel Microvision and close your already created project. After that, go to project and click on new Microvision project. After that, uh, you can save your project wherever you want to save it. For example, I want to give it a name of push button STM32F4 and give it a name. After that, give a name to your project files. Let's suppose push button. Now click on save. Here we are using STM32F4 discovery board, and this board comes with STM32F407VG microcontroller, and click on OK. After that, you need to select course from CMSIS, and in the device select the startup file, and STM Cube framework select classic, and STM Cube Hall you need to select, make sure you selected GPIO library, because we want to use GPIO pins as a digital input or digital output pins. And when you select these options, you may find these additional software component required options. So to resolve them, just click on resolve, and the Keel Microvision will automatically add these dependencies in your project. So all done. Now click on OK. Now we have created our project. So let's add a new file to our project. Add new, this is a C file, and give it a name. Let's say this is the main file of a project, and we will give it a name main. Now first we need to define our main function. Int main void, and first we want to use GPIO pins both as a digital and digital output pins. So to do so, first go to functions and open HAL GPIO library. So first of all, we need to configure GPIO D or port D pins as a digital output pins, and PA0 pin as a digital input pin. So now let's define two functions. Void GPIO, can say it initialize push button void, and similarly we want to initialize LEDs. So give them a name LEDs. Okay, so now let's write the definition of both these functions one by one. So first we will configure PA0 pin as a distant input pin. So if you go to this library, here you can find, to use any GPIO pin, first we need to enable clock to that GPIO. For example, we want to use GPIO A, so we need to enable clock to GPIO A. So this function is used to enable clock. So first we need to include the hash file for STM register definition file for STM32F4 discovery board for HAL libraries. Now first inside the initialize push button function, we need to initialize clock or enable clock for GPIO A, and after that we need to initialize, here it is, and this function first we need to define this struct, because this struct contains all configurations for GPIO initialization. So now let's create a instance of this struct. Let's give it a name push button. So first we want to use GPIO pin A. So go to definition of this function and first select the pin. So the pin that we want to use is GPIO, and here you can find the information about the pins. here you can see GPIO pin 0. So copy this and paste it here. So we need to select the pin first. So to select a pin, we first created a struct instead of the struct GPIO initialize, which contains all the settings for GPIO configuration. So with the help of pin member, we have selected GPIO pin 0, and after that we need to set the mode. The mode that we want to use is analog. So the mode that we want to select is GPIO analog mode slash input, and after that we need to make sure internal pull up resistor is disabled. So select pull, and here type GPIO no pull. Okay, so after that we will use this function to initialize uh, GPIO A pin A0 as a digital input pin. So to do so, first thing we need to pass to this function is GPIO name, which is GPIO A, and the second thing is that is we want to pass is the address of this GPIO initialization or type definition structure. So to pass this address, we need to pass the address of the instance of push button. Now we have configured the pin 0, which is PA0, as a digital input pin. Okay, now the second thing we need to do is to initialize push button pins as a LED pins as a digital output pins, when we have already seen in the last video how to configure GPIO pins as digital output pins. So to configure pins, let's first define this LED function. So to define this LED function, we need to enable the clock for GPIO D, because these LEDs are connected with port D of STM32F discovery port, and after that similarly initialize create instance of the structure which will contain all the configurations for these digital output pins. So let's give it the name LED. So now let's first select the pin. So here we have selected GPIO pin 12, GPIO pin 13, and GPIO 14, and GPIO pin 15 of port D. After that we need to define the mode of these pins, and the mode is digital GPIO pin GPIO mode output GPIO. Okay, so this will initialize these pin 12 to 13 as a digital output pins. After that we need to initialize these pins with the help of HAL GPIO initialize function. Now pass the name of the GPIO port, which is GPIO D, and also pass the address of this structure. Okay, so here we have configured pin 12 to pin 15 of port D as a digital output pins. So inside the main function, first we will call these functions to initialize button and initialize GPIO pins. So inside the while loop, first we need to read the state of the push button. So to read the state of the push button, this function GPIO HAL GPIO read function is used. This function is used to read the state of the pin, and the first argument to this function is the name of the GPIO port, and the second argument is the pin number whose state we want to read. So let's copy this function. Let's say inside the if, we call it inside the if. First argument to this function is the GPIO name, and the second argument is the GPIO number. So we want to read the state of GPIO pin 0. Okay, so this if condition will become true only when the state of the push button is active high. So when the state of the push button is active high, what we want to do, we want to make the LEDs which is connected with port D pin number 12 to pin number 15 active high. So to make those pin active high, we use Gpi Write function, and this function similarly takes three input argument. First is the pin name, and second is the pin number, and the third one is the state, whatever we want to make this pin. For example, if you want to make this pin active high, we will write GPIO pin set, and if you want to make the pin active low, we will write GPIO pin reset. So let's copy this function and paste it over here. So first we need to pass GPIO name. Second thing is that we want to pass is the pin numbers. Let's suppose we want these GPIO pins of port D to be turned on, and when the push button is pressed, these pins to be in active high state. So GPIO pin set. Else, if push button is not pressed, we want these LEDs to be remain in active low state. So just copy this line, and instead of writing this, just write GPIO pin reset. So we have written our complete code to read the state of a push button. So this program will read the state of GPIO pin A. If this is active high, it will turn on the LEDs. Okay, if the GPIO pin is and if the push button is not pressed, LEDs will remain off. So now let's upload this project to our STM32F discovery board. First let's compile this project, and we are getting 0 errors and 0 warning. So now let's build our project. To build our project, click on this build button. We have successfully compiled our build and can build our project. Now go to option target and click on debugger and select ST-Link, because ST-Link is the debugger available on STM32F4 discovery board. Now go to trace and enable the trace and select frequency of 16 megahertz. Okay, and okay. Now click on the load button, and here you can see flash loaded finished. And now if you press the push button, first click on the reset button, and if you press the push button, LEDs will turn on. As you can see, LEDs are turning on whenever we press the push button. So this is how we can use GPIO pins of STM32 as digital input and digital output pins.